Welcome back, students. We are still in 5.2 and let's review the mass function and the distribution function yet again. Okay. Wait a minute, this wasn't the right section of my notebook. Here it is. We talked about the mass function. It's a real valued function where the given random variable takes a value x. We have that's probability mass, and cumulative distribution function, the probability that random variable takes a value less than or equal to x. So we have accumulation here. Now let's move on to this example, mass function and distribution function. This time let's consider the relationship between one and the other. We're given a probability mass function here, and we are supposed to find out the distribution function. This is going to be relatively easy. The next one will be a little bit new. When the distribution function is given, let's find out the mass function. Now, how do you do those kind of things? Well, easy one first. When mass function is given, well, this time there's no way we can go back to the original sample space and so on. So we're not going to do any color coding or anything like that. Just look at the mass function. X value can take 0.5, 1.25, 1.75, and 2.0. Otherwise, impossible. So probability for those cases will be all 0. By the way, please make sure these are actually the mass function. 1/4, 1/8, 1/8, 1/2. Do they all add up to completely 1? Yes, indeed. So this is indeed a mass function, and these are indeed probabilities. Okay, how do we get the distribution function? Well, this is the smallest possible value that the random variable can take. So whenever x is less than 0.5, impossible event, so the probability will be 0. So that's where we're going to begin. Step function begins from 0. And then between 0.5 and 1.25, between this and that, well, only this one kicks in. So we have the probability of 1/4. And then after that, after 0.25, after 1.25, excuse me, up until 1.75, these two will contribute. So we have an accumulation, 1/4 plus 1/8. After 0.75, all the way up until 2.0, excuse me, these three will contribute. So we have that accumulation. Now, bigger than 2, then all 4 will contribute. So we'll have that accumulation, which will be fully 1. Consequently, we have something like this. Here is the distribution function. We have all these breaking points, 0.5, 1.25, 1.75, 2.0, and so on. And here are the accumulated probability. Nothing yet. 1/4, only first one kicked in. 2 of them kicked in, so 1/4 plus 1/8, these two I mean. And then now 3 of them kicked in, these 3 kicked in, so we have the accumulation of 1/2. And finally here, everything kicked in, all 4. We have cumulative distribution function like this. By the way, here is a graph of the mass function. Actually, I prefer the first picture. We have a bunch of dots, but our textbook author, and actually a lot of other authors too, put some artificial lines like these to see things better. Personally, I prefer the first picture, but they're all correct. Here is the probability, excuse me, cumulative distribution function. And I prefer the second function, second graph better, because you can clearly see which point is empty slot and which point is included. Solid is included. Hollow dot is, well, punctured out. Okay, how about the other way around? When cumulative distribution function is given, we have to retrieve the mass function. Well, let's see if this is really a cumulative distribution function. 0, 1/3, 1/2, 3/4, 1. Is it increasing? Yes, indeed. Alright, so this can be a cumulative distribution function. Where are the breaking points? 0.25. That's where something kicked in. So from 0 to 1/3, you're going to get that probability. Next breaking point is 0.5. 0.5. From less than 0.5 to greater than or equal to 0.5, something kicked in. 1/3 became 1/2. Accumulation is 1/2. It used to be 1/3. So what kicked in? The difference between these two, of course. 1/2 minus 1/3. That's how you get 1/6. Next breaking point is 1.25. 1.25. Something kicked in. 1/2 became 3/4. The accumulation became 3/4. So what kicked in? Taking the difference, you can get 1/4. Finally, 2.0, 2.0. That's the breaking point. And accumulation is 1. It was 3/4 before. So how much kicked in? The difference is going to be 1/4. In short, we get something like this. At 0.25, first breaking point, 1/3. Next breaking point, the difference between these two, 1/6. Next breaking point, the difference between these two, 1/4, and so on and so forth. Here is the graph of the mass function. Again, you can draw some vertical lines if you want to. Here is the graph of the cumulative distribution function. I'd much prefer the second picture. Hollow dot and solid dot. Hollow dots and solid dots are emphasized. Okay, great. We went through mass functions and distribution function. Now, let's take a little bit of breather, maybe just 2 seconds, because you can always pause this video. And then let's move on to the next concept, expected value. The expected value of a probability distribution is defined like this. Multiply the payoff value times the probability and sum them all up. If you don't like the sigma notation, you can use this kind of thing. x1 times that probability, x2 times that probability, x3 times that probability, and sum them all up. If you have hundreds of those, then you have to add hundreds of those. In that case, you'll have to use a computer. Standard deviation, kind of similar to what we did before. Take the variance. This expected value works like the mean, so take the deviation squared and then multiply by the probability. Deviation squared, probability. Deviation squared, probability. And sum them all up. That's going to be the variance. After taking the variance, take the square root to get the standard deviation. So you can find out the expected value, which corresponds to the mean, and the standard deviation, which corresponds to, of course, the sample standard deviation, using the probability distribution. In this case, the mass function played a huge role here because all those pi, all those pi's, or p of xi, those are mass functions. The probability that the random variable is taking the value xi. Let's work those out with an example here. Let's go back to the same earn model example. Okay, how about the first model? Red, green, blue. Yeah, okay, so same model as before. 0, 2, 3, alright? And what are the expected values? Well, 0 times that probability of red, of course, so 0 times 5/10. 2 times that probability of green, so it's 3/10. 3 times that probability, that's probability of blue, so 2/10. Add them all up, you're going to get the expected value, kind of like this. 0.15, 2 times 1, 0.3, and 3 times 0.2. Excuse me, I just got a wonderful idea. Let's do some color coding. Okay, we just did this. And then let's move on to the next example. We are looking at this random variable y, and the pair of values are -1.5, 0.5, and 1 respectively. And for each values, I have to multiply the probability. So -1.5 times this probability, which corresponds to the red ball, 0.5 times that probability, which corresponds to the green ball, and 1 times that probability, 0.2, the probability for the blue ball. Calculate, we are going to get this value. How about the expected value of the third random variable here? 1.25, or excuse me, -1.25 times the probability of red or green, so we get 0.8. 4.75 times that probability, which corresponds to the blue ball. Calculated, we get the expected value. Just using this formula over and over again. It's simple. Alright, let's work out the standard deviations. Here they are. For the first random variable, we have the values 0, 2, and 3, and their probabilities are 0.5, 0.3, and 0.2 respectively. These values. So each of those, and we multiply deviation squared. Deviation squared, 0 minus the expected value squared, times the probability. Next one, 2 minus the expected value squared. Another deviation squared times the probability. Add them all up and take the variance. Square root of it is the standard deviation. How about the next random variable here? The same thing. Deviation squared times the probability. Deviation squared times the probability. Deviation squared times the probability. By the way, deviation is actually the x value minus of -0.4 because the expected value was negative. And then add them all up, then we get variance. Take the square root, and then we get standard deviation. How about the third random variable? We take the variance first, and then take the square root. First value, -1.25, so we get the deviation squared and the probability, red or green. And then deviation squared and the probability. Add them all up, we get the variance. Take the square root, and we get the standard deviation. Amazingly, we are still not done with 5.2. We went through first probability mass function, and then we did some work on cumulative distribution function, and then we went through some relations between the two and going back and forth, and then we introduced expected value, variance, and standard deviation, and did some computation problems associated to those. We still have several more exercises to do. That is, how to get what you call that expected value and standard deviations from distribution function. From mass function, yeah, all these are mass function. You can get those. But how do you get those from cumulative distribution function? I'm going to do some exercise because we have already done one conversion here, but a little bit more will not hurt. And then we have still some further advanced topics to go. looks like one more video is necessary.